We are about to get into one of my favorite data sets of all time, discovering exoplanets. This is taken from the Exoplanet Hunting in Deep Space Kaggle competition. And, well, sorry, it's not really a Kaggle competition, it's more like a Kaggle data set. And you can see that the interest is in searching for new Earths. So the idea here is that there are a lot of stars in the universe, and these stars we've discovered are orbited by planets. And so there's a big interest in trying to discover, which stars have planets and which planets may fall in the habitable zone. So the idea behind it is that what you have are these light fluctuations. Okay, and so flux is a measure of light flux, and we're looking to see if the light flux changes periodically, and if so, there must be something blocking it. Presumably that's a planet. So to get started on this data set, I actually have a starter notebook for you, and you can click on it in the link. It's Discovering Exoplanets Starter Code. And when you click on that, you should see this. Go ahead and do that now. And what I want you to do is go ahead and make a copy of it so that you can have your own version. So click on File, and save a copy in Drive. And then it will create a copy and you have your own. And then maybe go ahead and relabel it. Discovering Exoplanets. It's no longer starter code. Well, it is starter code, but when you work on it, it's something different. So what we're going to do is we're going to use XGBoost to see how well we can do. And we're also in particular going to look at imbalanced data and some things that go along with that. Okay, so why did I give you starter code? I usually don't. Interestingly, I gave you Y and X here. So it's not for this, but you can go ahead and run this initial code, right? We know this code, import pandas as PD. Here's the URL from the Packed Publishing Hands-on Gradient Boosting with XGBoost and Scikit-learn GitHub page. And then importantly, I do want to highlight, this is a large data set, and it took a lot of time. So whenever you encounter that and you don't want to wait forever for code to run, you want to first try to work with a smaller number of rows, and you can set in rows equal to any number that you want. In this case, 1,000. We'll take the first one. I think it's the first 1,000 rows. And that's important here because the labels, and we can reveal that here, but it's also from the original Kaggle page. It includes 37 confirmed exoplanet stars. Why stars? Because it's the idea is that the star is what's being detected as having the exoplanet, okay? So these 37 stars are at the very beginning with label 2. So the first whatever you choose will include all of those 37. I guess I also printed out the shape just to confirm that it's got 1,000 rows as expected, but note that 3,198 columns, quite a bit. Now, the reason why I wanted you to have this code was for this. So it's not like a bunch of code. It's just, it's code to generate a light plot. And go ahead and run it. In effect, all it does is it allows you to plot one row at a time using like the time series that's there. So for instance, if you go up here to say row 0, we have all these measures of light fluctuation. Now, they're 3,198. So the idea is that by creating a light plot, you can actually look at it as it changes over time. So note that the function indicates you can put in light plot and just the index. So if I want to look at the first row, the 0th, I press Shift Enter. It says name, X is not defined. So there is some code missing from here. I thought I defined it here, didn't I? X should have been defined. Did I? Oh, it's because I didn't run this. I think it had already been up there. And that also explains why X is here, because you need it for the light plot. Yeah, so this, I hadn't run this. And by the way, that's actually a common mistake when you're copying someone else's notebook, you can scroll down and try to run something. Make sure that you've run code before it. Okay, so try that again. That's already been run. You can run it again, doesn't really matter. And there we have, so there we have the light plot itself. Now, the idea is this. There are periodic fluctuations here, and maybe you could like figure out that that's an exoplanet. Like, I don't know, like it's not obvious to me. I mean, there are a lot of fluctuations, but it's worth looking at some of these. So have a little fun with it. Just put in some light plots, okay? So if you pick a number 36 or under, 36 would be like the max, the last one. This should be evidence of exoplanets. And I think, again, it's not totally clear, but you might want to compare it to, say, another one that wouldn't be an exoplanet, which would be anything 37 or higher. And, I would encourage you to pick your own. Pick your own. Because you can see that there are fluctuations here, and some really steep ones. Is it consistent? And it can be fun to kind of try to find one that's clear evidence of an exoplanet. I think maybe I have one. If I look at some previous code, I'll show you one. I picked 2. Try light plot 1. See if you can find a better one. Look at that. That is a clear, look at these down, like the light flux is going down. These are clear periodic blockings of light. And so if you have that graph in front of you, you may be able to conclude that, hey, that's an exoplanet, right? And again, why? By definition, okay, if an object blocks light from a star periodically, okay, that means it's moving in front of it to do that. That is a planet by definition. And exo means it's not in our solar system. Okay, so have a little fun with it. Try. I think it's fun. I mean, I have not looked at all of these. Just try like some interesting numbers and see what you get. And okay, so that's an exoplanet. I'm not sure which part of it makes it an exoplanet. Because I'm not well studied in this, right? Is it like we've got these kind of little fluctuations here, but then we also have some really big ones. So maybe it's the really big ones because it's moving in a sine curve, which is pretty amazing. And again, if I choose one that's clearly not like 200, who knows what we'll get. See, and this is why I say that it's tricky, because you still have this sinusoidal kind of pattern here. But this has been identified as not harboring any exoplanets. So the idea is the following. We are going to use machine learning to actually try to determine whether it's an exoplanet or not, and we are going to use XGBoost.